Now we'll do problem from Fall 2010 Math 227 Test 2, number 1. The last poll of California governor election results in 49% for Jerry Brown, 39% for Mac Whitman, and the rest are undecided. What percent will the rest be? 49%, 39%. When you add them, that's 88%. So the rest will be 12%. Okay, now part A, find the expected number of votes for Jerry Brown by 15 voters. Well, if you have 15 voters, then either some of them for Jerry Brown, the others not for Jerry Brown. Not necessary for Mac Whitman, but for sure either Jerry Brown or not Jerry Brown. Okay, so that will define binomial distribution later on. But let's define a random variable. Let x, let's call that x1 be the number of votes for Jerry Brown. We know that this random variable will be binomially distributed with number of trials 15, and probability of success means somebody vote for Jerry Brown will be 49%, which is 0.49. Now then the expected number of votes for Jerry Brown will be n times p, which is 15 times 0.49. If you use your calculator, you will get 7.35. Okay, now that's for part A. Part B, find the standard deviation of the number of votes for Mac Whitman by 30 voters. You see that the idea will be quite similar. We will first define a random variable. Let x2, for example, be the number of votes for Mac Whitman. And this random variable, therefore, will be binomially distributed with number of trials this time is 30. And the probability of each success means the probability that one voter will vote for Mac Whitman is 39%, that is 0.39. Now the standard deviation of this random variable, the standard deviation of the number of votes for Mac Whitman, in this case will be denoted by sigma x2, which is given by its binomially distributed square root of 30 times 0.39, that's the p, square root of n times p times q. The q will be 1 minus the p, which is 0.61. Now if you use your calculator, this will be square root of 7.137, which is equals to 2.67516, I think, which I round to 2. Because this is rounded, let me use rounding notation. Okay, that's for part A.